All right, thank you for joining us today. And in this video, we are going to look at this example, right? So we have the joint function here, and we want to calculate expectation of y given x. So this is called the conditional expectation. So what is the formula for finding the conditional expectation? Y given x is integrating along the y, because our variable of interest is y here. Y, then we need to pick the conditional function, which is y given x dy, right? But the question given to us, or the in the question, we have the joint function, we don't have the conditional function here. So what we need to do is we need to figure out f of y given x. Now what is f of y given s? F of y given s is equal to the joint function divided by the marginal function. So the joint function of x and y divided by the given, right? Like this one here, y given x, so divided by this. So this is the same as this. Now we know this from the question, which is here, but we don't know the marginal of x. So it means that now we need to go and find for marginal of x. And we know that the marginal of x is integrating along the y-axis of the joint function with respect to y, right? So this is what we need to work with. But thank God we are not going to sketch any graph, because our x here is greater than 0 and our y2 is greater than 0. So actually we are going to have something like integrating from 0 to infinity over the joint function with respect to what? Y. So I'll pick this one and go and paste it in the second function. So now, as we said, this is integrating from 0 to infinity, the joint function dy. What is the joint function? The joint function is y, I think 1 plus x to the power minus this, e to the power minus y, 1 plus this minus 4. Yeah, I think I'm right. Good. So we are integrating this with respect to what? Y. But this one, what we are going to use, but this one we are going to use integration by substitution before we use integration by part, or I can teach you the gamma properties also from here. So here I'll let y or u to be equal to the whole of the function here. Oops. Or let me even use t, because of we are going to do integration by part again. So I'll let t here to be equal to the whole of this except the minus here. Now we are leaving the minus here because of the infinity here. So that when I have e to the power minus infinity, it will be 0. Good. So this will be equal to y 1 plus x minus 4. Now this implies that what will be y? Y will be equal to t divided by what am I going to get? 1 plus x to the power minus 4. Good. So when I'm making y the subject, I need to divide through by 1 plus x to the power minus 4. 1 plus x to the power minus 4. This cancel this, and I'm going to have y to be equal to this. Now that I know my y, I know this one to be equal to t, I need to also find for the y with respect to what? T, because our new variable is t. So now from here, what will be the y? The y over the t will be equal to 1 divided by 1 plus x to the power minus 4, and dy will be equal to 1 over 1 plus x to the power minus 4 dt. Now here we can also do the same thing that we've done here by finding, so dt over dy. When I do it, this is a constant multiplying this. So when I differentiate y, I'm going to get 1. So this one will be 1 plus 4, 1 plus x, this. And when I make y the subject here, this is over 1. So 1 will multiply this one will multiply this. Then when I make y the subject, so I'm going to have dt to be equal to 1 plus x to the power minus 4 dy. Then when I make y the subject, I'm going to still have the same thing, dt divided by 1 plus x to the power minus 4, which is the same as what is here. So any of them is going to work. Any of them is going to work. So let me use the first one that I did. Good. Now I know that dy, this can be written as, look at what is here. This is minus. If I have 1 over 2, this is the same as 1. Sorry. If I have 1 over 2, is the same as this, minus 1. So if I have 1 over 2 minus 1, this is the same as 2. So this one can be written as 1 plus 4 to the power 4 dt. That's nice. Now what we can do too is we need to figure out the interval for the t, right? So let's do that. Now this interval here is for y. So let's see, when y is equal to 0, what will be t? I'll plug in y here, which is 0, and everything here goes to 0. So y2 is going to be 0. When y is, let's say, equal to infinity, what will be t? Now when I plug infinity, infinity times this is also going to give us what? Infinity. So you see that we've changed all the variables. So what will be f of x? F of x will be equal to integration from 0 to infinity. What is for u? Sorry, what is for t? Our new t is also from 0 to what? Infinity. Now the question is, what is y? Y is here. So we are going to write t to the power t divided by 1 plus minus 4 times, we have this one here, so we need to write it down, times 1 plus x to the power minus 4 times, then we are going to write e to the power minus, but everything here is equal to t. So we are going to have it to be times e to the power minus t times, what is dy? Dy is equal to what is here, right? So I'm going to have it times 1 plus x to the power 4 dt. Good. So now, fortunate for us, this will cancel this, right? So that's what we are going to have. So we are going to have our function to be, now since we are integrating with respect to t, and this is not in terms of t, this is constant. So we are going to have something like 1 plus x for 0 to infinity, then t e to the power minus t dt. Now somebody will ask, we said when we are doing integration by substitution, when we are changing the variables, we need to make sure that all the variable changes to what? T, without any other variable, but we have x here. Now what you need to know is, here we were integrating with respect to what? Y. So we need to change all the variables to make sure that it suits what? T, in the idea that all the y variable will vanish from the equation and it will be left with just t. So because our x here is constant, so we can even bring it out with regards to what we're just trying to do, right? So that is the idea. Now with this one, we can use integration by part, or we can use the gamma property. Let me guide you through the gamma property before we use integration by part. So one of the nice property that we have for gamma is that gamma of alpha is equal to integration from 0 to infinity t alpha minus 1 e to the power minus t dt. So when you compare this here and this, you can see that they are almost the same. We have dt, we have e to the power minus t, e to the power minus t. We have integration from 0 to 0, integration is to the power to 0. So only thing that we have here is, we have t here, which is to the power 1, and t here, which is to the power what? Alpha minus 1. So this is also the same as this. So it means that t is equal to t alpha minus 1. This is to the power. Since the base are the same, we equate the exponent. 1 is equal to alpha minus 1, and this implies that alpha is equal to 2, right? So it means that this can be written as 1 plus x to the power 4 gamma of what? 2. Because now we know that alpha is 2. And if alpha is 2, then this one will be 2. So everything here is equal to what is here. So that. Now this gamma of 2 can also be written as 2 minus 1 factorial. And from here, 2 minus 1 factorial is the same as 1 factorial, and 1 factorial is 1. So it means that this is going to give us just 1 plus x to the power 4 for this. This is what you are going to get. But let's assume that they've not taught you gamma function and you need to use integration by part. Then going to integration by part, this is what you are going to get. We know that by integration by part, u dvin is equal to u vin minus vin du, right? So here, our u, when you compare this here, when you compare this here with respect to what is here, our u will be equal to t, right? And then our dvin will be equal to e to the power minus t dt, right? So here too, we want to do change of variables, right? So what we need to do is we need to change all the variables, right? So now we need u, which is here. We need vin, which we don't have. So it means that we need to integrate this because this function is differentiated so that we can get vin. So when I integrate the vin, I'll get vin. And when I integrate e to the power minus t, I'll have minus this. Then I have my vin now. I need the du. So I need to differentiate this function. So this, when I differentiate the u with respect to t, I'm going to have 1, which implies that the u is the same as what? The t, right? So that is the idea. So it means that when I'm doing the substitution, I'm going to have 1 plus x to the power 4, open bracket. What is u? U is t. What is vin? Vin is minus of this. So this is be minus t e to the power minus t minus integral of what is vin? Vin is here. So minus e to the power minus t. Then what is du? Du is the same as dt. So this is also going to give us dt right here. Don't forget we are moving from 0 to infinity, right? So I can write here f of x and take this one to the next page so that we can continue from there. All right, so this is what we have now. So for us to do the simplification, 1 plus x to the power 4, this is minus t e minus t. Then the minus here will be positive, right? Minus will be positive. But when I integrate this one, I'm going to have minus e to the power minus et again. So here was going to give us minus e minus t from 0 to infinity. So 1 plus x to the power 4. Now when I plug in infinity here, what happens? I'll have minus infinity e to the power minus infinity minus e to the power minus infinity minus. Then when I plug in 0 here, what happens? I'll have minus 0 to the power 0 minus e to the power 0. So what is going to happen from here? Now e to the power infinity here is 0. So this one will be 0. This one too will be 0. This one will be 0 minus 1. So we are going to have 1 plus x to the power 4. 0 minus 0 is 0. And then this one is going to give us plus 1. And we have this to the power 4 times 1. And this is 1 plus x to the power 4, which was the same as when you use the gamma function. So now this is our f of x, right? So let's go back to where we started. We needed this f of x here, right? So let me copy this one here and let's go and paste it from there and continue from there. So now we know our joint function, we know our f of x. So now we can look for this function right here. Paste. Now our joint function is y 1 plus x to the power minus 4, I think so, e to the power minus y 1 plus x to the power minus 4, right? So this is our joint function, which we are going to divide it by. What do we get for this? This one was 1 plus x to the power 4. When I simplify this, this one will be y. So you see, we have 1 plus x to the power 4, 1 plus x to the power minus 4. So let's assume that 1 plus x is a, 1 plus x is a. We are going to have a minus 4 divided by a to the power 4. Based on indices, this is the same as a to the power minus 4 minus 4, which is the same as a to the power what? Minus 8. Good. So this is what we are going to get at the end of the day. So this is going to give us something like 1 plus x to the power minus 8 e to the power minus y, then x 1 plus x to the power minus 4. So now this is what we have here. This here is equal to what is here. So now let's go and bring the integration that we wanted to do. So we wanted to integrate this function here. This is what we are looking for. So let me copy this one and go and paste it there. So now this is what we are looking for. So now thank God we have this guy here. We have this guy here, so we can paste this one here. So don't forget the interval for y is from 0 to infinity. So y times everything here. Everything here. I'm going to write everything here so I can copy and paste. Good. Times everything here, and I'm going to integrate with respect to y. So that's what I'm going to have. So this is the last step that we are going to go through. If we're able to figure out, the final answer will be the conditional expectation, right? That is y on x. So let's do that. What we can do is we can multiply the y here to this. So we are going to have from 0 to infinity y squared 1 plus x to the power minus 8 e to the power minus y 1 plus x to the power minus 4 dy. So the same thing like the one that we did. Let t to be equal to, t will be equal to just the one here without the negative, so that when you evaluate it at negative infinity, you get negative infinity and get to 0. So this one will be y 1 plus x to the power minus 4, right? And since we have y here, we need to make y the subject from here. You see that? We need to make y the subject from here. So let's do that one and see. So making y the subject from here, we are going to have, as we said, we divide this one by the function here, we divide this one by the function here. So y is going to be t divided by 1 plus x to the power minus 4. Do you see that? Yes, you saw that. So now we know this y here, or we can even square it. Y is squared, so we can square the y here, or we can plug in this one here by putting the square on it, but we can square it so that we have the simplification already. So when I square a over b, this is the same as a squared divided by b squared. So this is the same as t squared divided by, now look at this one. When I square 1 plus x to the power minus 4 squared, these two will multiply this. So this one will produce 1 plus x to the power minus 8, right? Not 16. It's going to multiply. Like you having a to the power 2 times 2. So you multiply them. You don't, like, okay, let me make this one 3. So you multiply them. You don't square it. So that is what you need to learn from there. So this is, so now we know y squared. We know this one to be equal to t. We need dy. So how can we get dy? We can get dy by differentiating either this function or this function. So if I'm picking from this function here, then the t over dy will be equal to, when I differentiate this function, this is y. So when I differentiate with respect to y, this one will be 1. So I'm going to have 1 plus x to the power minus 4, right? Then I need to make dy the subject. When I make dy the subject, I'm going to have dy to be equal to dt divided by 1 plus x to the power minus 4. So how did I do it? This is over 1, this times this times this. Then when I finish, I will divide 2 by this, and then I'll have something like this. Also, I need to look for the t intervals, right? The t intervals, as we did from the other one, the same thing. So if y is 0, when I plug in y here, everything goes to 0. So t will be what? 0. When y is infinity, when I plug in infinity here, everything here will be infinity. So the t interval will be when y is 0, t will be 0. When y is equal to infinity, t will also going to be infinity. right? So look at this one. I'll be coming back here so that we will see how we are going to write it out. So expectation of y given x is equal to integration from 0 to infinity. Now this 0 to infinity is now for what t, because we know that t also produce the same interval 0 to infinity. Now looking at this here, we need y squared, right? From where our last step here, we need y squared, and y squared is this. So we are going to write it here. So y squared is t squared divided by 1 plus x to the power minus 8 times. Now times we can see that we have this function here. So we need to write it there. So times 1 plus x to the power minus 8. Then e to the power, the whole of this, we said the whole of this is t. So we are going to have it to be minus t times what is dy. This dy here is equal to, what is it? Is equal to what is here. So we are going to have it to be dt divided by 1 plus x to the power minus 4. Nice. So now this will cancel this, which is very nice. So we are going to have it to be, now since the function now is in terms of t, this is a constant one. So I can factor 1 plus x to the power 4 out. And this one was going to be t squared e to the power minus t dt. This is supposed to be minus 4. I can write this one as the minus 4 here. I can write it as 1 plus x to the power 4 from 0 to infinity t squared e to the power minus t d. Now, if I want to solve this one, this is integration by parts. That we need to do it twice, 2 times. So this one I'm going to use the gamma. But if you want to do it, you can go through the integration by part that we went through with the first one that we did, this one. So the integration by part that we did here. So you do first integration by part, second integration by part before you get to the results. But gamma makes the thing very simple. So this one, when I'm doing integration by part, u will be equal to t squared, the will be equal to e to the power minus dt, right? So my vn will be equal to e to the power minus of, so I said u is equal to t squared, the vn is equal to e to the power minus t dt. So my vn will be equal to minus e minus t, and here my du will be equal to 2t dt. So because of another t here, that's the reason why I need to do another integration by part again. But I will use gamma. Now what is gamma? We saw that gamma of alpha is equal to, from 0 to infinity, t alpha minus 1, e minus this and this. So this is equal to this. This is equal to this. The integrals here is equal to this. So it means that this is also equal to this. So I'm going to have t squared is equal to t minus alpha. And then since the base are the same, I equate the exponent, and alpha will be equal to what? 3. So this is going to be 1 plus x 4 gamma of what? 3. And this is going to give us 1 plus x 4. Then this is 3 minus 1 factorial. Then this is 1 plus x to the power 4. And this is 2 factorial. 2 factorial is 2. So the final answer should be 2 times 1 plus x to the power 4. So this is with the interval s is greater than or equal to 0. So this will be the final results. And when you are using the integration by part, you should be able to get the same results. I don't want to go through the integration by part, but you can do it, right? You can do the integration by part for yourself, right? Or you are saying that I should do it. Do the integration by part yourself 2 times, and you will see that you are going to get this value right here. See you in the next video.